Hello, Romy. Goodness, my voice sounded rough just then. How are you doing tonight?
Hello.
Thank you for getting
Can
on
you
my
hear
phone.
me?
How are you?
Hello.
Can you hear me?
Yeah, can you hear me now?
Yes, I can hear you fine.
I'm good. How are you?
I'm doing fine.
This is the first time me talking
So
on
I
Zoom.
have. Oh, okay.
Yeah.
Um. Well, I have some plans for this evening for what we could discuss, but I'm always open to change that plan if I find that the group has a particular need. Would you mind in the chat function? Do you know how to find the chat function on Zoom?
I'm sorry, I couldn't hear that last part.
Can you find? I just sent you a chat. Can you see that?
Oh, yeah.
And just let me know. Is there anything that is of particular concern to you tonight?
Well, everything.
Okay. All right.
I'm
Well, then we'll
still
probably.
early
Hmm,
in my studies, so
makes sense. Do you have an idea of when you would like to take the test? Well, I'll get the recording going. Alex, can you tell me how many questions you have?
Sorry, turning off the mute. Not many, like 2 or 3 max.
Let's hear it. Go ahead.
So in my unique case, I am wondering if it's worth expediting the test to kind of get it out. So what would you say the natural progression of lifting your points, say 15 points would be? Is that like something you could kind of gauge, like estimate maybe a month extra studying?
It depends on where that comes from. I would say usually 10 to 15 points normally takes around 2 to 3 months.
Wow. Okay.
Yeah, it's not a fast process. Not usually. Um, what I can say is that the one exception to that is if you're missing points primarily because of timing issues. If you can address
Mhm.
timing issues first, that's something that can sometimes be addressed more quickly. But for
And
things
that
like,
actually leads, oh,
Mhm.
sorry.
Go ahead, leads to your
I was
next
actually going to
question.
say that leads into the kind of the next question about time. Is the test mostly hard for people given the time constraint, or is the test just considered hard? Because I took my first practice, I did no prep, I did it cold. I know some people have a feeling about that, but is it more like, is it mostly about the time or is it the content?
It is usually about time with certain specific content.
Okay.
What I found is that most people have certain areas of mathematics that they have forgotten. For
Yeah.
example, Megan mentioned geometry problems. That's a very common one. I used to know the formula for, a certain parallelogram, that kind of thing.
Yeah, Megan, I'm with
It,
you.
And if that's like you're like what I was 13 years old the last time I wanted to talk about parallelograms. What the hell is this? When that's the issue, then yeah, you just that's just content area. Um, However, once we handle those foundational content areas, it then gets down to time about how do I get through the problems as efficiently as possible.
Yeah. Thank you.
Hmm. Does anyone else have specific questions about that? In fact, it's kind of interesting. What I have planned for this evening usually does address a very significant timing aspect in practice tests. Um, but obviously it's not everything, but it's pretty significant. Does anyone else have general questions they'd like to bring up? All right, what I'm doing right now is I am grabbing my electronic copy of the 5-pound book so that if we end up with time to do more geometry than what I already have, I actually already have a few geometry problems selected. But if we end up having time to do more, I'll see what we can do there. In the meantime, let's go ahead and dive on in with what I have for tonight. Let me share the screen here. The GRE is in the quantitative section. It offers us very interesting challenges. And there are two challenges that I find that a lot of people are uncomfortable with. The first challenge is looking at a problem and asserting that the correct answer is that I do not know. You're most commonly going to hit that in quant comparison questions where you have the quantity A versus quantity B. Which one is larger? Are they always equal? Or is there no definitive relationship? The answer choice D for that is no definitive relationship. That is, we don't know. The other aspect that I find people are missing an opportunity on is what I call the what if mindset. And that's my intent to focus on this evening. Looking at questions that allow us to make certain assumptions about a problem and say, if I make this assumption, this would be my result. That result benchmark. And that benchmark allows me to make decisions on what the correct answer choice should be, or in some cases, eliminate wrong choices. And maybe you decide to make a guess, or maybe you would have a backup, more traditional solution that would get to the final correct choice. This idea of what if is really the heart of everything that is about choose your own numbers. Um, I'd like to get some emojis in the Zoom windows here. Are we familiar with this idea that many GRE problems actually allow you the opportunity to choose your own values and to test numbers instead of doing more traditional algebra? Yeah, got a little bit of that recognition there. This what if mentality is the heart behind that. But what I intend to do tonight is offer some more specifics on this. And I've got a sequence of, oh goodness, 15 problems. I'd be surprised if we do all 15, but we'll do our best. And what I want to do is to identify a repeatable what if. Something that shows up in this problem that can show up in many other problems of that variety. The most common applications, as I mentioned here, are in word problems and geometry questions, but it's also a very, very helpful path for quant comparison questions, especially in terms of making a quick assessment of which answer choices must be wrong. And if I know which answer choices must be wrong, if things start to go sideways in my solution, I can look at the problem and say, okay, I don't know what the answer is, but I know I should not select. And I can at least make a strategic guess, mark this, move on, and perhaps if I have time, come back to it later. So that is the idea tonight. Um, so I'd like to begin with actually this problem. First, quick confirmation. Do you all see this problem about at a certain school we have 118 juniors? I just want to make sure that everybody's getting the screen shared properly. Can you give me a quick yes if you're seeing a problem about 180 juniors? All right. Got at least one yes. So everyone can see this problem. Everyone take a moment, give it a try, and just type in done when you have an answer. Chen, by all means, what is your concern? You can get in the chat or you can get on the microphone.
Didn't have a concern. Did I raise my
Oh,
hand by accident?
raising your hand say you can see it. Okay, got it. All right,
I'll lower that.
thanks. All right, everybody take a few moments, give it a try. And again, just please type done in the chat if you are done with the problem. Give it Alex. Anyone else, when you're done, please let. Just out of curiosity, did anyone here do this the very traditional approach? Say I have 118 juniors. They all have an average score of 88, plus my 100 seniors, who all have an average score of 92. Do that in mathematics. Divide by, that'd be 218, and that will be your final average. Did anybody in the room do it that way? This is a way to solve this problem. You would arrive at the average for all the juniors and seniors combined. But we don't have to. What if we had the same number of juniors and seniors? I put them on like opposite ends of some idea here, and I have my juniors with an average of 88, and I have my seniors with an average of 92. What if I had the same number of juniors and seniors? What would be the resulting average when I combine them? Anybody type in the chat or get on the microphone? But what would be the average in this hypothetical? 90. Do I have the same number of juniors and seniors? No, I do not. So that tells me right at the very beginning that answer choice C must be wrong. The two quantities are not equal. I actually have more juniors, and I have fewer seniors. What does that tell me about where the actual average is going to land? Greater than 90 or less than 90? I need closer to 88. If I have more juniors, then I know my actual average is going to be somewhere between 88 and 90, which means that quantity A will be less than 90. Your correct choice here must be answer B. So, what are we seeing here? We're just going to keep some, I'm going to keep some records here of just certain things here. So one example of what if here, I have two opposing elements that become combined. What if they were the same? Any questions, comments, concerns about how a what if mentality works on this problem? We had a specific call out for geometry at the beginning here from Megan. So why don't we take a moment and see there's in a geometry context. Again, take a few moments. Type done when you are done. Damalar or Damalare, please guide me in the pronunciation if you can get on the microphone. I always want to make sure that I pronounce everyone's name correctly whenever possible. Thank you for volunteering your choice there. Did I pronounce your name correctly? Is it Damalare?
Yeah, close enough.
Close enough. Oh, I'm sorry. Would you like to correct me?
No, it's all right. It's Damilari.
Damalare.
Just-
Okay, thank you. Thank you for sharing the answer that you selected. I'm also intrigued because Alex, you jumped on this very quickly. You said you were done in seconds.
I hope I'm right for that. Was it not? Just tell me, am I right for it to be like an impulse, like you got it right looking at it?
Well, I will tell you that the correct answer is in fact going to be choice A.
I can't see the list of answers. Where is it?
Oh, well, sorry. I've forgotten here. These are our answer choices for this question type. Quantity A is always
Got it.
greater. That's choice A. Answer choice B is quantity B is always greater. Answer choice C is the two quantities are always equal. And answer choice D is the response is not conclusive.
So in my mistake, then I thought it was C.
Okay. Well, let's discuss our what if. What if? And Alex, what kind of triangle do we have here?
Right. So I looked at that as the 90 degrees.
So what if this is a right triangle? Have they told me it's a
Yeah.
right triangle?
I mean, they didn't explicitly.
No, they did not actually. And so we have to ask, this is a what if, because they did not tell me that it's a right triangle. But what if it is? Can you recall an equation that applies to all right triangles?
What was that?
Can you recall an equation that applies to all right triangles?
Oh, half base times height.
That's every triangle. Every triangle's area formula is 1/2 base times height. Specifically for right triangles, have you heard of the Pythagorean theorem?
Yes. A squared plus B
Yes.
squared equals C squared.
Yes. A squared plus B squared equals C squared. In fact, Pythagoras did not actually discover or deduce the Pythagorean theorem. Pythagoras is the person who got credit for it because he led a cult about mathematics, and apparently it was really a cult. Like we're talking like one of the members was apparently executed because they argued that numbers could be irrational, and that was just not sitting well with this group of people. That is one way to handle mathematical discussions, I suppose. Anyways, if this is a right triangle, I have 6 squared plus 8 squared squared. I have 36 plus 64 equals c squared. I have 100 equals c squared, which means that c would be 10.
Yeah.
So if this is a right
Okay.
triangle, my third side should be 10.
Stupid 0.5. Okay.
But it's not. It's too big. And if that side is bigger than I expected, what does that tell us about angle x?
By default, that angle is going to be larger than that 90 degrees that was presumed.
Yep. Other way around, Megan.
Yeah.
If the opposite side is larger than you expected, your angle was also larger than we expected. The sides of a triangle go by, like, as I increase in angle, if you imagine like if you have an imaginary line between my fingertips, as I increase that angle, that side is also increasing. So here we see the opportunity. Oh, and by the way, this is also an opportunity just memorization. You have some common right triangles here. 6, 8, 10 is a very, very common right triangle. It is what is called a Pythagorean triple. It is one of the very few integer combinations that fits Pythagorean theorem. The reduced version of it is 3, 4, 5, and that's also very common. Again, we have this idea of what if. And what we're looking for here is in a geometry context. Am I allowed to make geometry shape the most approachable version of that shape? Let's do something along a similar vein here. Everyone take a moment and which one do I want to do? I want to do this one. Everyone take a moment, give this problem an attempt. Eugene, I'll come back to that in just a moment. I have one answer in, but I don't have anyone else saying done. Is this problem taking a bit more time, presenting a bit more challenge than some of the previous ones? Feel free to tell me in the chat or in the microphone. Are you experiencing a bit more of a challenge with this problem? Or do we think yes, Alex? Mm-hmm. We have a parallelogram. But does my parallelogram look like this? Does it look like this? Like, how flat does this parallelogram become? Or actually, I keep a cardboard mailbox here just to illustrate this, like, to where I'm always working with students. You have this parallelogram. The sides are going to stay parallel, but I don't know exactly what angle it would have. What angle would we want to be in this parallelogram? And here is our what if. What is the most convenient parallelogram that we could have?
A rectangle.
Of a rectangle. So what if this were a rectangle? I have a parallelogram. A rectangle is still a parallelogram. Two sides of length 10, two sides of length 5. My area there would be 50. So I know the area of the parallelogram could be 50. So again, if we're thinking of our A, B, C, D answer choices, I know that C is eliminated because they're not always equal. And I know that B is eliminated because there is at least one instance where quantity B is smaller, not larger. But now the question becomes, is my area of the parallelogram always greater? And the answer to that is no. The correct answer to this problem is, in fact, D. It could be 50. But as I take that parallelogram, that rectangle, and let it collapse onto its side, that area gets steadily smaller and smaller and smaller until it becomes basically a flat line. That area could be practically 0. This is actually an example of what I call a principal geometry question. And principal geometry questions rely on this idea of when I can apply symmetry to a shape. Applying the most symmetrical version of a shape always creates your minimum and maximum properties for that shape. And so here, if I have a parallelogram and I make my parallelogram the most symmetrical variation I could have, which in this case would be a rectangle, that would have the maximum possible area for that parallelogram. So this one is actually D. Questions, comments, concerns on this particular variation? You added there was a shortcut to the previous problem. Thank you for that question, Alex. I'll come back to that in a moment. The shortcut here is actually recognizing that we are almost, but not quite, a 6, 8, 10 right triangle. I say I'm almost that 6, 8, 10. That's the 6, 8, 10 is the result if I had that what if. If you don't have that 6, 8, 10 memorized, then there isn't a shortcut here. You actually do need to apply Pythagorean theorem in this what if and say, if this were a right triangle, then C would be 10. This problem, I don't view this problem as actually possible without a what if mindset. Not a shortcut. I don't think this problem is actually possible because you have to have the what if of what if this is a rectangle and then realize that that is an optimized version of that shape and you could just let it collapse down if need be. As to how often is the answer D? Um, the answer is D, honestly, probably about 1/4 of the time. They're actually pretty good at making a very even distribution of answer choices across the quant comparison section. Or I should say the quant comparison question type. It's not its own section, technically. How are we feeling about this? I'd like to look at one where there's a very specific what if. And so far, I've been taking problems from the Manhattan book. This next one is actually one of the Manhattan Prep practice tests. But one problem in a practice test won't kill us. Everyone take a few moments. Give this one a try. Let me know your answer choice, or just you can say done if you're done and you don't want to share your choice. Would anyone like to give voice to any concerns about this problem? Either on the microphone or in the chat? I would also like to know if you have selected an answer choice. Yes, Megan. We would be picking values for A, B, and X. And the correct answer here will actually be D. Again, let me just move things around. We are picking values. The question is going to be what value? This A, B does not equal 0. that is meant to be read as A times B is not 0. Open question, Daniel. What does that tell me about A and B individually?
That one of them is not 0.
One or both?
Because if
Both.
it's 0 times anything, then it can't be equal to 0.
Neither one can be 0. So A and B are not 0. I'm also told that A to the x must equal B to the x, which may lead us to think that A and B have to be the same because they are raised to the same exponent. Now here's my what if. Is there something here that could be 0?
The x.
What if x were 0? If x is 0, I would be forced to say A to the 0 equals B to the 0. Is that a true statement? Is A to the 0 equal to B to the 0? The
1.
answer is always. This always leads to 1 equals 1, no matter what A and B are. Our what if here, if x equals 0, A and B could be anything. There are other paths to show that the correct answer is D, but that what if is, I believe, the fastest path. If I make x equal 0, it's always 1 equal 1, and it could have been 1 million to the 0 versus 1 to the 0, or it could have been negative 11 to the 0 versus 11,000 to the 0, and it would still be 1 equals 1. So we've seen a few geometry. Our next what if I am allowed to use I call them trick numbers, or identities, a 0, a 1, or a negative 1. Questions, comments, concerns there? Be very intrigued to see what happens with this one. Stepping aside from quantitative comparison, going to more traditional multiple choice. Everyone take a few moments, give this problem a try. So we do have a traditional approach here. Traditional approach would look like creating a rate, time, work chart, or any to organize the information we have here. I have a row for Sabrina. I have a row for Janice. And I have a row for the two of them together. Sabrina can do it in 8 hours. Janice can do it in 13 hours. There are variations on how to deal with a problem like this. One variation is to say that if they never tell me the size of the tank, I can pick, but let's say it is one tank. And rate times time equals work. So therefore, rate equals work divided by time. Keep in mind that we do have a calculator. It is a very clunky, very unwieldy device on GRE, and it only has minimal functionality. For example, the calculator cannot do exponents, but it can do division. And 1 divided by 8 is a neat decimal, 0.125. 1 divided by 13 is not neat. It is approximately 0.077, but they did say approximately. So I'm allowed to make that approximation. Now, question to the group. If Sabrina's rate is 0.125 and Janice's rate is 0.077, what is their combined rate? When they work together, what is their rate? When I say Sabrina plus Janice, what am I actually adding? The joy of rate and work questions is the way you describe the rows is always what's happening with the rates. You literally add the rates here. They have a combined rate of 0.202. They're still trying to do one tank. And 1 divided by 0.202 is approximately 4.95. And so we'd have choice D. Now that's our traditional approach. Let's talk about a what if. What if Sabrina and Janice were identical? And this is going to take too much to type, or sorry, to handwrite. What if both Sabrina and Janice could assemble a tank in 8 hours on their own? When I put them together, how much time would I expect? Please respond in the chat. If they could each do it in 8 hours individually, put them together, how much time would they need? They would need 4 hours. But Janice is slower than that. So the correct choice must be larger than 4. The other side, what if both Sabrina and Janice could assemble in 13 hours? I put them together, how much would they need? They would need 6.5 hours. But Sabrina is faster than that. So the actual time must be less than 6.5. This is a slightly more rare, but very similar mindset to the problem we had at the beginning. What if they were the same? I know they're not, but what if they were? We have another example here of two opponents, Sabrina and James, and they become combined. And then I start by asking, well, if they were the same, what would be my result? questions, comments, or concerns? And I do this problem with an average pi. I am not familiar with the term average pi, but my suspicion is yes. Because Megan, I suspect that you're asking whether or not this can be treated as a variation on a weighted average, which technically it is. I'd have to see more about the approach to understand what you mean by average pi, but my suspicion is the answer to that is yes. But I love this what if mentality. The more I develop it, the more I start to see faster solution paths to a lot of problems. Strategical would I approach all questions this way? What do we have to do it the standard way again? Yuchen, honestly, this what if approach is actually not my first approach for rate questions, but it is my first approach for any type of mixture problem like we have here. It is very close to my first approach to number testing and quantitative comparison. And it is definitely my first approach in a geometry question where they leave things a little bit off from what I expect. Looking at this and saying, I almost would have expected that to be a right triangle, but I don't think it is. Looking at this and saying, it's a parallelogram. It would be nice if it were a rectangle, but I don't know if it is. It's those kind of problems are when it is my primary approach. And in fact, it is a primary approach in a problem like this, not in terms of getting the solution, but in terms of eliminating choices quickly. Don't do anything pen on paper. Just look. How do I immediately know that the answer here will not be A or B? Type in the chat window or get a microphone. Megan, it's interesting. What do you know about these variables? Too many variables does not always mean that A and B are wrong. Ah, I do not know that, Domalare. I do not know that A is greater than B is greater than C. I know that they are integers. Do they have to be positive? Mm. Isn't that sneaky? We are not told they have to be positive. They could be negative. Or is there an integer that is neither positive nor negative that actually would also be allowed? And here's our what if type of problem. What if can anyone think of an integer that they could all be equal to? The one integer that is neither positive nor negative. What if they were all 0? There's nothing in this problem preventing that. 0 equals 2 times 0, which also equals 4 times 0. They could all be 0. Quant could be 0 equals 0. Now, does that immediately answer the question? No, it's not. But it puts us right off the bat by recognizing that if I can find any example where they are not equal, I know my answer. And you could, for example, make C equal 1, in which case B would equal 2 and A would equal 4. So here you'd have 4 plus 2, and here you'd have 4 plus 1, and those would not be equal. And so your correct choice here is D. Now, Eugen, I hope you're over there wondering, is this the way that Chris would actually do it? And I actually wouldn't do it this way. What I would do, and this is something that the traditional approach, or my recommended approach for quant comparison, look at what is the same and use that to your advantage. Quantity A and quantity B both have A as the components, which means and I'm really comparing B versus C. And I know that 2B equals 4C. That was good, which means that I know B equals 2C. So I could say this is really just 2C versus C itself. And then I could also say, well, I can subtract C from both quantities. And if you're not familiar with the idea of adding or subtracting around these quantities to try and unify certain elements in the problem, look into that. The ability to unify elements around the quantities and get common terms together is immensely valuable. It makes so many problems so much faster. And now you can see that our question now becomes, is C 0 or not? And the answer is, I don't know. But that, what if they were all 0? What if I'm allowed to use one of those trick numbers? That eliminates A and B right off the bat. Questions, comments, concerns? I'd like for us to close with one last problem. In my opinion, it is a very challenging problem from the 5-pound book. It can require a lot of brute force calculation if I want to approach it that way. But it is very, very approachable through a what if mentality also. Everyone take a few moments, give it a try. Oh, and note here that this is an indicate all such numbers. So you could be selecting more than one of these choices, and I will go ahead and tell you in advance that for this particular problem, you would be selecting more than one of them. Everyone take a few moments, give it a try. Alex, that is a correct statement. There is no partial credit, unfortunately. How are we doing? Can you give me any type of reaction where you feel you are in the chat? Eliminated one answer thus far. Yeah. This problem, in my opinion, actually requires a what if mentality. And you may have used it intuitively without realizing it, but I want to make it pulled out and explicit here. The average is greater than 40. None of the buildings are more than 80. Which of the following could be? This mixture of inequalities or limit setting, along with a statement that there is not one definite answer, this is what tells you that this problem will be about testing limits and using our limits to define boundaries and benchmarks, and using those benchmarks to derive the correct answer. Our what if here is I have 4 buildings. I have 4 2-year-old buildings. My what if every other building is exactly 80 years old? Running that opposite extreme. That's my what if. I have 2-year-old buildings versus 80-year-old buildings. My next what if is establishing a benchmark. What if I had the same number of each? What if I had 4 2-year buildings and 4 80-year-old buildings? In that scenario, what would be the overall average for the whole block? The average age would be a lot higher than 8. I'd have 8 total buildings, but my average age would be 41 years old. It is grade 40. This does work. So I know I could, in fact, have 8. And then I also know that anything higher than 8 is also an option. Because anything higher than 8 is giving me the opportunity to say, what if all of the other buildings are just more and more and more 80-year-old buildings? And I'll keep pushing that average age higher and higher and higher and higher. Technically, to be sure, you'd probably have to check 6. You'd probably have to check 4 versus 2. But you may realistically decide, and this would be my decision on the test, 41. Oh, how did I get 41? It's actually literally the average of 80 and 2. 80 plus 2 divided by 2. If you've got equal numbers of these buildings, the average age of the whole block is just the average of 80 and 2 itself. Literally the number right between them. Realistically on the test, I would look at this and I'd say 41 is so close to my boundary that I think this is the extreme edge of what I could do. I would not be able to do anything less than this. I would take 8, 11, and 40, and I would just move on. And so we close actually where we began, with one of the more common what if elements that shows up on this test. What I have 2 opposing entities. What if they were the same? That creates a benchmark that I can work against, and that allows me to, in many cases, either eliminate or select correct choices. All right, my friends, this is our hour. Thank you for being so involved tonight. I've been really appreciative of everybody willing to get on the microphone when they could, everybody being active in the chat. And being expected, I could tell that you were really working on these problems and trying to work through this technique. You should have all gotten an email from me about 5 minutes before the start of this meeting with just a link to the webinar room. Did everyone here get that email? I would appreciate it if you all just confirm. And you did not. Well, here is hoping that the chat does not go onto a public broadcast because I just put my email out there to everyone. I am hoping and intending to make this a fairly regular occurrence, at least once a month, if maybe not more often. And so if there are future topics that you would like in another one of these free pep hours and you would like for me to build a session around that, let me know. This is only my second one that I've done. I'm really enjoying them. I've been actually doing this for, Jesus, more than a decade now. I've been doing this for a bit. But this is my first time doing something that's not specifically tailored to one person or specifically tailored to one class. But if anybody has future requests, I'm happy to take care of that. Well, thank you all, everyone. Have a lovely evening. I wish you all very, very sincerely the best of luck in your work on this test and in your applications. And I hope you end up with very, very high scores in a few months. I'm glad you liked it, Alex. I hope you all appreciate it. I hope you all benefit from it. Any last comments or concerns before I close out the room?